morning and welcome to our live coverage of the capture of SpaceX's Dragon on its 17th commercial resupply mission to the International Space Station. You're getting a live view from the space station of Dragon as it is now flying over the North Atlantic Ocean at over 17,000 miles per hour. Dragon has just received the go to depart the 250-meter hold point, also known as the keep-out sphere. This is one of multiple checkpoints built into today's processes. It allows teams on the ground, both at SpaceX in Hawthorne, California, and here in Houston, both views that you can see on your screen, to check the systems on the spacecraft and ensure it is ready for continued approach to the space station. Throughout the morning, we'll see Dragon continue to move closer to the station before stopping at the 30-meter hold point. That's one last opportunity for teams to check Dragon's systems before its final approach to the space station. And once it reaches about 10 meters from the station, or 30 feet, astronauts aboard will use the Canadarm2 to grapple the spacecraft from their position in the station's cupola module. They'll then turn controls over to the ground, and robotics controllers will continue to use the Canadarm2 to bring the spacecraft up to the station and berth it to the Earth-facing side of the Harmony module, also known as Node 2. We're live this morning from Mission Control Houston, where flight controllers are monitoring all systems aboard the International Space Station and in communication with teams in Hawthorne. Our flight director this morning is TJ Creamer. He's in communication. You can see him at the bottom of your screen. He's in communication with all of the teams here on the ground, gathering all of their data. And the Capcom to his right, that's Brandon Lloyd. He's in communication with the ISS crew, the crew aboard the station. He's relaying all of the information gathered here on the ground today. The visiting vehicle officer this morning is communicating with both Hawthorne teams and teams here in Mission Control Houston. That's David Harshman. Throughout the morning, we'll continue to see Dragon approach. It's currently about 225 meters away from the International Space Station. And once it reaches that 10-meter hold point, Canadian Space Agency astronaut David St. Jacques will take his place in the cupola module, backed up by NASA's Nick Hague, and they'll use the Canadarm2 to reach out and grapple the spacecraft. Currently aboard the International Space Station are NASA astronauts Nick Hague, Christina Cook, and Anne McLean, Canadian Space Agency astronaut David St. Jacques, and Roscosmos cosmonauts Alexei Ovchinin and Oleg Kononenko. This is the first spaceflight for McLean, St. Jacques, Cook, and Hague, and Cook's spaceflight was recently extended. She will spend about 328 days on board and set a new record for the longest single spaceflight by a female. To give a little perspective, the Dragon cargo craft you see here has a diameter of about 12 feet and a height of 23.6 feet. It's loaded for this mission with about 5,500 pounds of supplies, equipment, experiments, and more. And when it arrives today, SpaceX's Dragon will be the sixth vehicle parked at the space station, joining two Soyuz spacecraft, two Russian Progress resupply crafts, and Northrop Grumman's Cygnus 11 spacecraft. Dragon now 200 meters away from the International Space Station, and we're looking for an on-time capture at about 6 a.m. Central Time.
Station Houston, Dragon is inside the 200-meter keep-out sphere. You now have the authority to issue an abort if no comm with Houston and the light is outside the corridor.
And station copies.
As you heard, Brandon Lloyd, Capcom for today, communicating with the crew aboard the station and relaying the information that Dragon is now go to depart to enter the keep-out sphere, kind of an invisible line around the space station. It's now 182 meters away from the station. And the crew on board actually has the ability to send an abort command to Dragon in case something were to go wrong. However, things are moving smoothly this morning as we continue to progress with Dragon's approach to the space station.
Houston Station on 2 for updated Block Bravo.
We're listening.
As expected, we've got changes in Monitor 1. No change to Block Bravo and Monitor 3. Monitor 1, we've got the light inside the corridor. The vehicle size matches the overlay. The light is offset from the circle by about 4 vehicle widths to the port and half a vehicle length forward, and circled dead center in the corridor.
All right, those are following the trends we expect as well. Thanks.
Astronauts this morning are communicating with the ground teams from inside the cupola module on the International Space Station. That's the windows that provide a great view of not only the Earth, like we see here, but also Dragon and the Canadarm2. On the left side of your screen, you can see a view of that cupola workstation that the astronauts are using this morning.
Station Houston on 2, heads up for you. We're going to move slightly the camera on monitor 1 to get a better look at Dragon. So you're going to see that motion on monitor 1.
Okay, we copy. Thanks for the heads up.
Dragon was initially scheduled to arrive to the International Space Station earlier. However, after a little bit of a delayed launch due to an issue with the main bus switching unit, which was identified on April 29th by teams on the ground. And that MBSU distributes power to 2 of the 8 channels on the station. You can see the remove and replace in your bottom left-hand screen. The International Space Station needs to be at an optimal configuration for Dragon to be captured and berthed. And with the successful completion of robotics work using the Dexter, or Special Purpose Dexterous Manipulator, on the station, it gave a backup string of power to the Canadarm2. The SpaceX Dragon you see currently is actually making its second mission to the International Space Station. You can see that small picture of a space station under the P on the capsule. This capsule itself also flew on SpaceX's 12th commercial resupply mission, now currently circling the Earth at about 256 statute miles. You can also see a clear picture of that grapple fixture, that 3-pronged spot in the middle of the capsule. That's what astronauts will be targeting with the Canadarm2 this morning when they reach out and grapple at about 30 feet away from the International Space Station. Dragon is currently at about 92 meters away from the space station. The next major milestone this morning will be that 30-meter hold point, where teams will continue to perform checks on the vehicle before it continues its final approach to the space station. Throughout the morning, we'll be answering your questions. If you hop on over to Twitter and use the hashtag AskNASA, we'll be on the lookout to answer them live on air. We do have one already this morning asking if we are sending up any fun or special or personalized items in the cargo for Dragon for the astronauts aboard the space station. Astronauts do receive care packages from home, items from family members or friends. They expect those on some commercial resupply missions. This also brings science and research and hardware and other crew supplies to the International Space Station. We're currently in a satellite handover for the International Space Station. This happens periodically and is tracked by the ground teams. We'll regain pictures very soon from the space station.
Station Houston on 2, we're done moving around the camera on monitor 1. It's back to you.
And we copy, thanks.
As you can see, we've regained imagery and satellite communications with the International Space Station. There are several satellites that we use to keep in communication with the astronauts on board. This is called TDRS, or the Tracking and Data Relay Satellite System. We're continuing to take your questions this morning with the hashtag #AskNASA. This one from Thomas, who is asking what experiments are on Cargo Dragon and what experiments will be coming back on its return. There are several experiments going up on Dragon, including a photobioreactor and some tissue chips in space, as well as the Orbiting Carbon Observatory 3. And we actually have a video to tell you a little bit more about each of those. And that's only some of the science and research that's going up to the International Space Station. To go into a little more detail about each of those, this is the Orbiting Carbon Observatory 3. This examines the dynamics of Earth's atmospheric carbon cycle, and it will actually be installed robotically on the Japanese experiment module exposed facility. This measures and maps carbon dioxide from space. It helps us understand the relationship between carbon and climate, and it collects measurements to quantify the specific type of atmospheric carbon dioxide. Being able to have this type of observatory on the space station allows sampling during all of the sunlit hours and also targets local mapping of emission hotspots to help us better understand carbon emissions on Earth. These precise measurements allow scientists a better understanding of those carbon dioxide sources on the surface of Earth and how those may vary during different seasons. Another experiment going to the space station is called the photobioreactor. Current life support systems in space use physiochemical processes like steam and chemical reactions to generate oxygen and water and remove carbon dioxide from the space station. This investigation would demonstrate the ability to use biological processes to create a hybrid life support system. It tests the cultivation of microalgae for food as well as part of a life support system to generate oxygen and consume carbon dioxide. This could be beneficial for future long-duration missions, as it may be able to reduce the amount of food and water and other essentials that crews need to bring from Earth. This type of research is critical for NASA to understand and overcome the challenges of long-duration spaceflight, and it's necessary for a sustainable presence on the Moon and future missions deeper into the solar system like Mars. Another experiment is tissue chips. These are also known as organs on chips, and they're small devices that contain human cells in a 3D matrix. Scientists use these to test how the cells respond to stresses, such as being in a different environment, microgravity, drugs, and genetic changes. There are 4 different tissue chip in space investigations on this flight, including lung host defense and microgravity, which uses lung and bone marrow organ on a chip. We also have the cartilage bone synovium microphysiological system, which looks at how spaceflight affects musculoskeletal disease. Another looks at the space-related stressors on the brain and blood barrier. That's organs on chips as a platform for studying effects of microgravity on human physiology. And the last examines kidney cells, the effects of microgravity on the structure and function of proximal and distal tubule MPS. Knowledge gained from these can help protect the health of astronauts. It can also contribute to better treatments for conditions on Earth and give us better understanding of diseases that we deal with here on the ground. Hermes is a reconfigurable on-orbit facility. It provides a platform for investigators with applications to asteroids, planetary science, and exploration. It gives researchers insight into the formation and behavior of asteroids, comets, impact dynamics, and planetary evolution. It's capable of accommodating up to 4 experiments at a time, and it can operate for hours or days or even months. It is equipped with lighting to illuminate the experiments as necessary, and multiple cameras to provide imagery or video for monitoring from the ground. Dragon is currently at the 30-meter hold point away from the International Space Station, and teams on the ground are going through checks of what would occur if an abort were to happen. Of course, things are running smoothly this morning. They're also checking with teams at Hawthorne, California, to ensure SpaceX's Dragon's systems are all go to continue its ascent to the International Space Station. As the series of checks continue at this 30-meter hold point, there will also be a go, no-go from the flight controllers to make sure everything on their end checks out. This is a very important milestone because the next will be the arrival of Dragon at the capture point of about 10 to 12 meters from the International Space Station. Once Dragon reaches that capture point, about 10 to 12 meters away from the space station, Canadian Space Agency astronaut David St. Jacques will use the Canadarm2. He'll be backed up by Nick Hague of NASA, and they'll reach out and grapple the spacecraft. They'll then turn controls back over to the ground and robotics controllers here, who will use the Canadarm2 to berth the spacecraft to the station's Harmony module on the Earth-facing side.
Station Houston on 2, we are ready for you to confirm the 30-meter hold per step 4 of 1.102, and you're also go to maneuver to high hover. And I've got a couple more big picture words for you when you have a good time.
Houston station copies. We see prior range of 31 and a sec range of 30.8. Show it in hold, and we're ready for those words.
So the reason we took over your camera a few minutes ago is because we noticed a line on Dragon that we weren't expecting to be there. Our initial looks at it are we don't expect any interference with the operations today, but Robo's coming up with some bonus lines to your backaway cue card today. So I want to give you a heads up that that's coming.
And Houston, we copy that, and we noticed looks like a cable that's maybe 6 to 10 feet in length running down from kind of the bottom of the capsule down into the service module, if that's what you're talking about.
That's one and the same. And, of course, our assessments from the HD views we got are that we don't see any interference with the grapple fixture at this time. But if you have any assessments for us or any words on how mobile you think that line is, I'm sure folks would welcome it.
And we copy that, Houston. And we haven't seen any gross motions out of it. Looks like it's connected close to the grapple fixture and maybe loose on the other end. If we see anything squirrely happen, we'll let you know.
Appreciate it.
That was Capcom Brandon Lloyd relaying information from the ground to the crew on board the International Space Station, discussing upcoming milestones for Dragon, currently still in that 30-meter hold point. We're continuing to take your questions throughout the morning with the hashtag AskNASA on Twitter. This one comes from Dan, who wants to know if he is able to see Dragon from Earth tonight in the Philippines. It doesn't appear that Dragon or the space station are visible tonight from the Philippines, but you can actually look that up using the website spotthestation.nasa.gov. You're able to type in your location, and the website will be able to give you the next time and date you can expect to see the International Space Station fly over where you live. It does look like the Philippines will get a good view of Dragon and the space station coming up next on May 16th and 17th. This is a live view from the Canadarm2 on board the International Space Station. You can see Dragon right there on your screen, still at the 30-meter hold point. After being released from the 30-meter hold point, it will continue its ascension up towards the space station, and that Canadarm2, now at the bottom of your screen, will reach out and grapple the spacecraft once it is about 10 meters away. As you can see, the space station is currently in an orbital nighttime. The station is flying at over 17,000 miles per hour, and it orbits the Earth about every 90 minutes, so crews on board the International Space Station see 16 sunrises and sunsets each day. Canadarm2 is now in high hover, and that is the robotic arm, and that is the position which will eventually prepare it to drive in to capture the vehicle. That's one of the things that had to be completed while at that 30-meter hold point for Dragon. And teams here are still checking out the systems before giving the go for Dragon to depart that 30-meter hold point.
Houston Station, SSRMS is in the high hover position.
Houston copies. We concur, and get your back away cue card out. I've got the new line to add.
Ready to copy.
Okay, I need you to add line 11. The failure is line moving into the capture interface, preventing capture. The response before free drift is back away. Response after free drift is back away retreat.
Copy all. If the line gets into the capture volume, basically, lifting is going to prevent good capture. Before free drift, back away. After free drift, back away, retreat.
That is a good readback. And with that, let us know when your review is complete and you're ready for Dragon approach.
Copy.
We're continuing to answer your questions with the hashtag AskNASA on Twitter. This one from Jim asking what the reach and capacity is of the Canadarm2. And yes, you are correct, Jim. The arm on shuttle and on station, this being the second version of that, cannot lift its own weight in Earth gravity. However, in microgravity, things are a little bit different. And at 57.7 feet, the Canadarm2 can actually maneuver with 46,000 pounds. To put that in perspective, an Asian elephant is about 12,000 pounds, so quite a few.
Station Houston, Dragon is ready to proceed to the capture point. Expect approach to resume shortly.
Copy.
Station Houston, Dragon has begun approach from 30 meters. Monitor per step 5 of 1.102.
As you just heard, Dragon has now departed the 30-meter hold point. That's its final hold point for the morning. All crews on the ground gave it a go to depart that hold point, and it will move next to the capture point of about 10 to 12 meters from the station.
Station Houston, how copy? Step 5.
And Houston Station copies. Block Bravo for Monitor 1. We see the light in the corridor. The vehicle size matches the outline. The light is offset from the circle about half a vehicle width to the port and about a quarter forward. And the circle is offset from the center of the corridor, half a vehicle starboard, half of the length forward. Monitor 3, we see no change there. It still has the half forward and half length starboard offset for the circle. Everything else lines up.
That's an as expected nominal block Bravo. Thank you.
Approach is looking nominal this morning, this view from the Canadarm2 of Dragon, as it has departed that 30-meter hold point and is now moving into the capture point about 30 feet from the space station. Dragon is moving much slower now than it has been throughout the morning. This move from the hold point to the capture point takes about 15 minutes. These are very deliberate movements, as required when near the space station to ensure a safe approach. And once it's at that hold point, Canadian Space Agency astronaut David St. Jacques will use the Canadarm2 to grapple the spacecraft before he turns controls over to the ground for berthing to the Harmony module later this morning. As Dragon continues its approach to the space station, we have another Ask NASA question, asking why ground teams carry out this docking procedure rather than the astronauts on the space station. It's actually kind of a joint operation. Currently, ground teams are monitoring the vehicle and performing system checks, as well as commanding it to move away from that 30-meter hold point into the capture point. But crews on board the station, specifically David St. Jacques of Canada, will reach out with the Canadarm2 and grapple the spacecraft. Afterward, he will turn the controls back over to robotics controllers on the ground, who will then use the Canadarm2 to bring the Dragon up to the station's Earth-facing side of the Harmony module. Dragon is now under 23 meters away from the space station, and Henry wants to know what will happen with Dragon after it is unloaded and fulfilled its mission. Dragon will remain on board the space station for about a month as crew members unload the supplies and research and hardware on board, but they will also reload it with about 4,200 pounds of research, hardware, and supplies that will return to Earth. It'll depart, as I said, about a month from now, and it'll safely splash down in the Pacific Ocean, returning that hardware and research to Earth. Dragon is now 20 meters away from the International Space Station and has about 10 meters to go before it reaches that capture point, the space station flying 254 statute miles above Hawaii. Dragon is now about 12 meters from the space station and almost at that capture point. You may have heard the flight teams talking with the crew on board the station earlier about a cable that is external to the vehicle. It usually comes off of the capsule during launch and didn't this time, and teams have determined it does not interfere with the grapple point, and capture this morning is continuing as scheduled. We're in another short satellite handover in less than a minute to sunrise as the International Space Station begins to approach the United States. Next major milestone for Dragon will be to reach that capture point about 10 meters away from the space station, and astronauts aboard will use the Canadarm2 to reach out and grapple it before ground teams bring it up to berth with the Harmony module later this morning.
Station Houston on 2, confirm capture point hold per step 6 in 1.102.
Station copies. It works.
As you just heard, the confirmation that Dragon is holding at the capture point just a little bit over 10 meters away. Now that it has arrived, teams are conducting a final go and no-go. That's the final steps that everything is checking out, and the crew can take controls of the Canadarm2 before driving it in to capture the vehicle.
And Houston station for Dragon. We've confirmed capture conditions, and we're ready for Dragon capture.
Houston copies, stand by for capture.
Standing by.
Station Houston, you are go for capture sequence. Perform step 4 in 1.110 Dragon capture and begin monitoring the backaway cue card.
And Houston station copies, we're go for capture. Just for your SA, we're going to wait 3 or 4 minutes here to let the sun get out of our face. And we'll step into step 4 in 1.110.
Sounds good.
As you just heard, the crew is go for capture, and they are holding until the lighting is a little bit better on their side. They're stepping through their procedures, and when they decide to drive that Canadarm, we'll start to see the arm get closer to the Dragon capsule and that capture point, which you can see that three-pronged little grapple fixture right in the middle of the capsule. Station will be crossing the terminator line soon. That's the difference between daylight and darkness, as it's currently flying over Canada at over 17,000 miles an hour. Dragon is holding steady at the capture point. Next step is for astronauts to use the Canadarm2 to drive in and grapple the spacecraft. They're awaiting their desired lighting conditions, and everything is proceeding as scheduled. This is a view from the Canadarm2. We will see it over the next several minutes slowly get closer to the Dragon. And on the left is a view from the cupola workstation where Canadian astronaut David St. Jacques is commanding the Canadarm2 this morning. Canadarm2 is now in motion and aligning with the vehicle. When the Canadarm is in motion, there is a no exercise rule on the space station to prevent any vibrations from disturbing the position of the arm. Astronauts now maneuvering that Canadarm2 into place and starting to drive it toward the capsule. Canadarm2 now 5.5 meters away. The arm now 4 meters away from that grapple fixture. Now 2.5 meters away from the space station, and Dragon is in free drift. The arm is now 1 meter from Dragon. The arm is over the pin. And we have capture of the SpaceX Cargo Dragon on its 17th commercial resupply mission to the International Space Station. Capture occurred at 6:01 a.m. Central Time as the station and Dragon were flying over the North Atlantic Ocean. Canadian Space Agency astronaut David St. Jacques used the Canadarm2 to maneuver towards the Dragon and grapple that fixture in the middle of the capsule. This comes after a 2-day journey for Dragon and its launch on May the 4th.
And Houston station on 2, capture is complete. Your go for post-capture reconfiguration.
Well done, well captured. Way to make it look easy.
To all the teams around the world, we welcome to the ISS the Dragon spacecraft as part of the SpaceX 17 cargo resupply mission. Dragon left Cape Canaveral 2 days ago and brings to ISS more than 2,500 kilos of supplies, equipment, and scientific equipment from institutions and companies around the world. It's noteworthy that this is the second flight of this particular capsule, which flew the SpaceX 12 mission. En tant que Canadien, chaque utilisation de Canadarm2 me rend fier. As a Canadian, I'm proud every time we use Canadarm2 for free fire capture. There's not always a Canadian crew member on board ISS, but in a way, the Canadian engineers and technicians who built and support Canadarm2 and Dexter, they are always on board, if not in body, at least in spirit. Their ingenuity and sense of innovation regularly echoes up here and is an inspiration to us all. And as we speak, robotics operators and support teams in Houston and Saint-Hubert are busy preparing to remote control Canadarm2 to berth the Dragon spacecraft on a docking port at the bottom of the Tranquility node. And even before the launch, Canadian Robotics was involved in repairs to the ISS power system that were required for today's operations. The extra effort of the joint Canadian and U.S. operations and engineering teams working around the clock saved the day. Such is the value of the partnership of this international program. My crew and I are proud to be part of this today, representing the dedicated teams of talented people who, every day, make the seemingly impossible a reality. Ensemble, nous continuerons d'explorer toujours plus haut et plus loin. We're looking forward to exploring higher and farther together. Bienvenue à bord, Dragon. Welcome on board, Dragon.
Beautiful words, David. Go team. We're all proud to be part of this mission as well. And congratulations on a successful capture.
That was Canadian Space Agency astronaut David St. Jacques, who just used the Canadarm2 to grapple SpaceX's Dragon and attach it to the International Space Station. Initial capture occurred at 6:01 a.m. Central Time, with capture confirmed at 6:03 a.m., flying over the North Atlantic Ocean. Controls of the Canadarm2 will now be turned back over to the ground, and robotics controllers here will use that to maneuver the SpaceX Dragon to attach it to the space station's Harmony module. Thanks for joining us this morning as we have been covering the capture of the SpaceX Dragon on its 17th commercial resupply mission to the International Space Station. Dragon was captured this morning by Canadian Space Agency astronaut David Saint-Jacques using the Canadarm2, and he has now turned those controls back over to ground teams who will later berth the vehicle to the Harmony module on board the station. Capture occurred at 6:03 a.m. Central Time, with the space station flying over the North Atlantic Ocean, and our coverage of the berthing of the SpaceX Dragon to the International Space Station will begin at 8 a.m. Central Time. This 5,500 pounds of crew supplies, hardware, research, and more will stay attached to the International Space Station for about a month. But the next milestone for the morning is that berthing to the Harmony module. That wraps up our capture coverage for now, but we hope you will join us for that 8 a.m. coverage of the berthing. This is Mission Control, Houston.